Make sure that you're well. Make sure that you're well on board. You have something really spicy to eat, be it grits and cheese, your chicken, that your roti, your pylori, your bacon saltfish, your habanero, whatever it is. Make sure that you don't fall asleep in this session. Don't forget, please put all your questions in the Q&A and put your comments in the chat. Remember, you must use your own link and you can pre-read the assignments. Those are posted on the consortium's website and it's posted for every week. And you can also read and see recordings of the video presentation that have been recorded each week. Next slide. So this is a very important part of the course. That is getting your CME credits. Your CME credits are provided by the Accreditation Council of Continuing Medical Education via the Trinidad and Tobago Medical Association. However, for you to claim your CME credits, you have to apply each and every time for each and every session by clicking on the link that we put in the chat before 2 hours after each session closes. And you get credits for each didactic session and for each skills and practice sessions. However, there's a caveat. You've got to pay for these CME sessions. Not very expensive, $49 US. For most people, if you're a Trinidad and Tobago resident, please, Haley's going to put my link, my email in the chat, phenry@earthmedic.com. If you're a TNT resident, please send me a request for CME credits. There's a little, we had been running into a little bit of problem, but it's not a big problem. So those of you who have a credit card that is linked to a US bank, you will not have any problems with your payment. If, however, your credit card is linked to, say, for instance, a Caribbean bank, you might get a message saying that they are not accepting your payment. Don't worry, this is a good thing. It's a security measure that has been put in place by your bank in the Caribbean. Just send me an email titled CME Credits, and I will tell you how to navigate that. Next slide. Okay, so now we have come to the big moment, and that is we are going to hear from Dr. Andrea Seeley. Dr. Andrea Seeley is a meteorologist at the Caribbean Institute of Meteorology and Hydrology, CIMH. She also lectures in meteorology at the University of the West Indies, Cave Hill Campus, Barbados. She's also a supervisor and advisory committee member for PhD and MPhil students in meteorology and environmental studies. Additionally, Dr. Seeley is the chair of the Pan American Regional Steering Group of the World Meteorological Organization's Sand and Dust Storms Warning Advisory and Assessment Systems, WMO, SDS, WS, a member of the WMO, SDS, WS Steering Committee, a member of the Caribbean Aerosol Health Network, and coordinates the CIMH Dust and Air Quality Forecasting Center. She's a member of the American Meteorological Society and the American Geophysical Union. She also coordinates various outreach initiatives of the CIMH. It is indeed an honor to introduce Dr. Seeley. She is here to give us a really important talk. Welcome, Dr. Seeley.
Thank you. So I can go ahead?
Yes, please.
Okay, thanks. Just go ahead and share my screen with you. Okay, so you can see the presentation and you can hear me clearly?
Clearly, Doc.
Fantastic. Well, good evening to everyone. It indeed is a pleasure to be here. And as Paula said, I am a meteorologist and an atmospheric scientist by training. So you're going to see quite a little bit about the meteorology, weather, climate, atmospheric science type stuff behind our common air pollutants. and some other relevant information related to the learning objectives of the course. Okay, so just a little bit of a reminder about the learning objectives and a little bit about my approach. So I am going to be describing how weather, climate, some of the atmospheric science, basic chemistry, etc., behind the respiratory irritants, ozone, PM 2.5, and others, and how they do impact climate-sensitive respiratory diseases. I'll also be describing how climate change might impact indoor air quality, and also a little bit about how climate change, or hint as to how climate change may make air quality regulation more complex and difficult. I think we could explore this a little bit more when we do our discussion. So that's something that probably will be out there for us during the discussion part after the presentation. I'll also be identifying populations that are vulnerable to degraded air quality, and a little bit about describing, and we will also discuss this as well and think about this as well as we go along, how health professionals can protect the vulnerable patients. I'll also explain about wildfires, how they're impacted by climate change, and the direct and indirect health implications. Also, how climate change would increase the risk of complex disasters due to combined and cascading events, and identifying particularly vulnerable patients and families, and also what we can do to help those, how to mitigate risk, and so on. So just a little bit of overview. In 2019, according to the WHO, 99% of the world population was living in places where the air quality guidelines established by the WHO were not met. So basically, at least 9 out of 10 people breathe polluted air globally. Air pollution is known as the silent killer. Both ambient, which is outdoor air pollution, and indoor air pollution, especially household pollution combined, cause about 7 million premature deaths every year. And this is as a result of increased mortality from stroke, IHD, COPD, lung cancer, and acute respiratory infections. Now, in terms of these 7 million deaths, more than 2 million are in the Southeast Asia region. More than 2 million are in the Western Pacific region. And when you look at the combined numbers in areas where you have a lot of developing countries, the developing countries are going to make up the majority of these deaths. And the WHO air quality guidelines sets goals to protect millions of lives from air pollution, and I'll talk about that shortly. So when this translates to how many people are dying every minute, air pollution kills 13 people every minute, according to the WHO statistics, due to things like I mentioned before, like lung cancer, heart disease, and strokes. So the WHO air quality guidelines, known as the AQGs, set goals to reduce air pollution. And in the WHO AQGs, there are key air pollutants. These are not the only pollutants, but these are the key air pollutants that are mentioned, are referred to in this document. Ozone, particulate matter, PM 2.5 and PM 10, nitrogen dioxide, sulfur dioxide, and carbon monoxide. Now, the air quality guidelines set out to achieve the goals to reduce air pollution by 1, setting interim targets that help countries to continuously work on improving their air quality, and secondly, recommending air quality guideline levels to protect people from air pollution. So you have the current levels and to get down to the recommended AQG levels. So this is a table from the most up-to-date WHO Global Air Quality Guidelines from 2021. These are the recommended levels and interim targets here in the table seen in this slide. And what these targets represent, or these guidelines, they are evidence health-based standards for specific air pollutants that countries are going to be convinced or to adopt. And these guidelines were initially set in 2005, the AQG levels. They were updated in 2021, and as I mentioned. And what is interesting is that most of these new recommended limits for concentrations and exposures are lower than the previous targets or guidelines that were published before. So the 2021 update shows how air pollution affects many aspects of health, even at low levels or lower levels than what was previously thought. So I'm going to talk a little bit about these pollutants. And because I'm an atmospheric scientist, I'm going to put the atmospheric science in there, which encompasses the weather and climate aspect. So the first one I'm going to talk about is ozone, O3. And this is found primarily in the troposphere and stratosphere. The troposphere is the layer of the atmosphere where we live, and the stratosphere is the layer above us where the good ozone is, which is the ozone layer, and that's where 90% of the ozone is located. The 10% is in our sphere, our layer of the atmosphere, the troposphere. That is what we call the bad ozone. And this tropospheric ozone is mostly created as a byproduct of human activities, creating photochemical smog, which is a secondary pollutant, and sunlight is required for our production of ozone. So the concentrations of tropospheric ozone would be higher during afternoons and summer months. So the times of the day and the time of the year where you get most of your sunlight. So it has some of the characteristics. It has a pungent smell. It's an eye irritant. It also irritates the mucous membranes of the respiratory system, aggravating chronic diseases such as asthma. Even in healthy people, exposure to relatively low concentrations of ozone for a few hours during periods of moderate exercise can significantly reduce lung function. And these symptoms may include chest pain, nausea, coughing, pulmonary congestion. And ozone also damages vegetation, causing significant reduction in crop yield and crop quality. So this is a schematic showing various pollutants, and I'm going to talk about some of these over the next few slides after this one. But these are various pollutants that are involved in the production of photochemical smog. And this consists of both primary and secondary pollutants we see here. So we have our primary pollutants directly emitted from natural and anthropogenic sources. And you see things like nitrogen oxides, sulfur oxides, volatile organic carbons, particulate matter. And then these go on to form secondary pollutants. So we have our O3, we have our other sulfur oxides, we have our acyl nitrates, PANs, and I'm going to talk about those in a little while with respect to nitrogen oxides. All right, so peroxyacyl nitrates as well. So this is very interesting how a lot of these pollutants, especially the key pollutants, they actually get together or they combine chemically to form these secondary pollutants. So particulate matter, PM2.5 and PM10. Particulate matter is a mixture of solid particles and liquid droplets found in the air. PM10 are the inhalable particles with diameters 10 micrometers and smaller, and PM2.5 are the fine inhalable particles. These have diameters 2.5 micrometers and smaller. And some of the sources of particulate matter are construction sites, paved roads, fields, smokestacks, fires. And I'm going to talk about some more of these sources with respect to air quality in the Caribbean as we go further into the presentation. And the harmful effects of the PM2.5 and PM10, they contain microscopic solids or liquid droplets that are easily inhaled. The PM10 size particles can get deep into the lungs or even the bloodstream. The PM2.5, which are the finer particles, these pose the greatest risk to health because these are going to be even more easily inhaled and more deeply inhaled or absorbed into the bloodstream than the PM10. But another thing that is a harmful effect of particulate matter is that there are particulate matter events such as Saharan dust events or other dust events, emissions, volcanic emissions and others, or even just dust from construction sites, roads, etc., that cause reduced visibility. And that is a harmful effect because then you can have accidents being caused as a result of this. So this is a graph from the WHO showing Caribbean countries with annual mean concentrations of PM2.5 in urban areas that exceed the WHO recommendation at the time, which would have been 10 micrograms per meter cube. And these are 11 countries here, and these are probably not all of them. But 11 is still a lot considering the size of the region, the number of countries and territories we have. And this schematic here, these figures, figure A and figure B, show the PM 2.5 and PM 10 settlements or locations of settlements with these data from 2010 to 2019, also from the WHO. And what you will notice is that the majority of the data on particulate matter would be more concentrated in the upper and middle income countries. And what you would also notice is that the density is higher in those developed countries. There's a scarcity of data and a scarcity of observations in the developing countries. So in regions like ours, or countries in regions like ours. So then we move on to nitrogen dioxide, NO2. Nitrogen dioxide is a part of the highly reactive NOx gases family, so oxides of nitrogen or nitrogen oxides, but it is used as the indicator for the larger group of NOx. The primary source would be burning of fuel, so emissions from vehicles, cars, trucks, buses, emissions from power plants, and off-road equipment would be primary sources. Now, NO2 exposure irritates airways in the human respiratory system. Short periods could aggravate respiratory diseases, particularly asthma, coughing, wheezing, or difficulty breathing. Longer periods contribute to the development of asthma and potentially increase susceptibility to respiratory infections. Now, nitrogen dioxide, when you look at NOx, these nitrogen oxides, they start mostly as NO, okay? But the volatile organic carbons in the atmosphere convert NO to NO2, and this reacts with others to form nitric acid and the peroxyacyl nitrates. But then in the presence of sunlight, NO2 converts back to NO and produces ozone. So remember I said a lot of these things are family, okay, in terms of how they interact with each other and are pollutants, primary and secondary pollutants. And then we also have sulfur dioxide, SO2, and this is used as the indicator for the larger group of sulfur oxide, SOx. So the largest atmospheric source will be the burning of fossil fuels by power plants and other industrial facilities. But then there are some smaller sources such as other industrial processes, natural sources such as volcanoes, locomotives, ships, and other vehicles, and heavy equipment that burn fuel and that have a high sulfur content. This fuel would have a high sulfur content. So in terms of SO2, short-term exposure irritates the respiratory system, and that makes breathing difficult. And the SO2 emissions that lead to high concentrations in the air would generally also lead to the formation of other sulfur oxides. So these sulfur oxides can react with other compounds in the atmosphere to form small particles, and these small particles are going to contribute to the amount of particulate matter we have in the air, PM 2.5 and PM 10, are fine and are small particles that are easily inhaled. And then we get to carbon monoxide. Carbon monoxide, CO, it's a colorless, odorless gas, and it can be very harmful when inhaled in large amounts. CO is released by combustion, and exposure to high concentrations reduces the oxygen that can be transported in the bloodstream to critical organs. So in terms of indoor air quality, CO is a big problem. High concentrations can cause dizziness, confusion, unconsciousness, and death. Now, outdoor air quality is rarely compromised by CO, but in the outdoors, if you have elevated levels, it may affect persons with some types of heart disease. But in terms of carbon monoxide, indoor air quality is a really major concern, as in CO compromising that. And I'll tell you a little bit about why when we get to indoor air quality. So in terms of carbon monoxide, outdoor sources would be vehicles or machinery that burn fossil fuels. And the indoor sources would be things like unvented kerosene and gas space heaters, leaking chimneys and furnaces, gas stoves. If you leave a car running in an attached garage, that is a serious problem as well. Operating a grill indoors or in a garage. So carbon monoxide is a really serious concern in terms of indoor air quality and the fallout from that as well. So before we move on, I'm going to go to Zoom poll question 1. And what I'm doing with the questions to make it fun, we're doing them before we get to the section associated with the question, just to get a feel for what's going on. So this Zoom poll question 1 states, how do you think Caribbean air quality levels and the associated impacts compare to those in the US? Lower, higher, or the same? How do you think Caribbean air quality levels and the associated impacts compare to those in the US? Lower, higher, or the same? So what do you think? So let's take a minute or so to see what you guys think. All right. Okay. So 54% think lower, 31% higher, and 15% the same. All right, so stick a pin there, and we'll see in a minute, well, less than a minute, what really happens, or what really the outcome would be, the answer to this question. Okay, so moving on. Air quality in the Caribbean. Exposure to particulate matter in 26 cities across the Caribbean and Latin America was found to be more than twice the US standard in a 2005 study. The uncertainty this study had was about ground level ozone due to lack of data. So air pollution is a major contributor to morbidity and mortality, especially in developing countries, and this includes Caribbean countries. And this is due to things such as a lack of air quality regulations and enforcement of any air quality regulations if they exist, and also things like socioeconomic, geographic, and climatological factors. All right, so I think you're seeing the answer here. So according to the WHO, in terms of the Americas subregions, attributable mortality and disability adjusted life years due to outdoor air pollution. In the Americas subregion B, which includes the Caribbean, we have 30 deaths and 307 disability adjusted life years per 1,000, which is higher than the 28 deaths and 200 disability adjusted life years per 1,000 for the Americas subregion A, which includes Canada and the US. So I think we have an idea of what the answer is to that question. And I know some of you probably are surprised by that. Okay. So in terms of air quality in the Caribbean, what are these sources? So sources include burning fossil and biomass fuels to generate electricity for heating, cooking, and transportation. So PM 2.5, PM 10, carbon monoxide, nitrogen dioxide, lead, sulfur dioxide, ground level ozone, carbon dioxide. Wind-blown dust, wildfires, gases, and particulate matter emitted from volcanic eruptions. And what are the origins? The origins could be local or regional sources, so within the region, but the sources could also be a far distance away from the region, distant or global sources. And we're going to see a little bit about both of those type of sources as I move on in the presentation. So transportation of volcanic ash and dust across long distances, for example, has been shown to contribute to the air quality, the air pollution, and respiratory diseases in some Caribbean countries. So a study of air pollution and respiratory health among elementary school children in Guadeloupe was done in a study in 2015 and by Amadeo. And that study found that the mean PM10 levels in over 70% of the schools exceeded the WHO air quality guidelines. And the culprit was strongly suspected to be Saharan dust. So just to give you an idea of how the Saharan dust episodes could look, this picture was taken by Alexander James over Barbados. And this was the 2020 huge mega dust event we had June 2020. And we called it the Godzilla dust event, where a huge plume of Saharan dust traversed over the region into the southern US over that time frame. And we called it the Godzilla dust event. And look how polluted the air is in terms of the Saharan dust. So continuing on that vein, humidity interacting with dust from the Sahara has been shown in studies to produce particulate matter in Barbados, Grenada, Trinidad and Tobago, and the US Virgin Islands. And this has resulted, based on those studies and the results of those studies, they found that it resulted in increased visits to the emergency department due to exacerbated asthma. And what should be noted is that the particle size of Saharan dust varies from less than 5 micrometers, as reported from studies done in Barbados and Bermuda, to between 5 and 30 micrometers, as other studies would have reported. And to shed a little bit more light on this, I have some research from Professor Joseph Prospero. He's now Professor Emeritus from the University of Miami. He has been a pioneer in Saharan dust research. And the Ragged Point Station on the east side of Barbados in St. Philip is the longest running dust record or observational dust record globally. And that station was established by Professor Prospero. And in his study in 2003 to 2004 with Barbados daily dust concentrations, he found that about half the dust mass was PM 2.5. And even more than that was PM 10. And so when you had these intense dust incursions in the Caribbean, as measured by the Ragged Point Station, the WHO air quality guidelines for PM 2.5 and PM 10 would have been exceeded significantly because of these Saharan dust incursions. So continue a little bit more about air quality in the Caribbean. Ash, volcanic ash as well. So a study in 2013 found that ash from the Soufriere volcano in Montserrat was linked to an increase in asthma admissions in Guadeloupe after the 2010 eruption. And that is because fine volcanic ash or dust, which is a combination of particulate matter, sulfur dioxide, and other toxic gases, along with water vapor, their particle sizes are less than 60 micrometers. So you're going to get a fair amount of PM 2.5 and PM 10 size particles in there as well. And this is a picture I took outside my parents' home when we had the Soufriere St. Vincent 2021 eruption. And if you see how coated the outdoors is, and the thing is that a lot of that also got indoors, even with the windows closed, with the doors and windows closed. So the ash was everywhere. So that is an issue as well. So moving on now to indoor air quality. Around 2.6 billion people cook using polluting open fires or simple stoves fueled by things such as kerosene and biomass, which would be wood, animal dung, and crop waste, and coal. And annually, close to 4 million people die prematurely from illness that is attributed to household air pollution. And this would be because of inefficient cooking practices, such as using polluting stoves that are paired with solid fuels and kerosene. And it was found that the breakdown in terms of these deaths, 27% are due to pneumonia, 18% from stroke, 27% from IHD, 20% from COPD, and 8% from lung cancer. So indoor air quality, and just to emphasize a little bit more about this. So why would indoor air make us sick? You have nano-sized pollution particles coming in from the outdoors. You have mold toxins. You have fine particles and chemicals from humans and our processes, our anthropogenic processes. You have fibers, you have odors, you have volatile chemicals from furniture and construction materials. And the effects of indoor air pollution would be things like confusion, headache, anxiety, sneeze, cough, irritation in the nose and throat, lung infection, genetic disorder, heart ailment, COPD, and asthma. And what I wanted to point out here and emphasize is that almost 50% of deaths due to pneumonia among children under 5 years of age are caused by particulate matter that is inhaled from household air pollution. And this was very startling to me, and I wanted to bring it to your attention as well. So this is something we really, really must pay attention to. So let's go on to Zoom poll question number 2. Wildfires are predicted to increase under all future climate scenarios. True or false? What do you think? Wildfires are predicted to increase under all future climate scenarios. True or false? I want to see what you think. Okay. And 89% say true, 89% say true, 11% say false. All right, let's see. Let's see. Okay. So climate change and wildfires. Now, the interesting thing about wildfires and the concerning thing about wildfires is that they significantly affect the global carbon cycle. Now, how? They are going to occur in ecosystems that would normally store large amounts of terrestrial carbon, which would be your forests, areas with lots of vegetation, etc. The vegetation sequesters, it stores carbon. But if you have these wildfires in these ecosystems and you destroy your vegetation, vast quantities of carbon dioxide, CO2, would be released. And we don't want that. So what is going to happen is that this may accelerate a positive feedback loop in the carbon cycle, which you keep releasing CO2 into the atmosphere, which we don't want, and that would cause or possibly cause rising temperatures. Now, another thing is that wildfire smoke contains particulates and toxic combustion. So it can affect respiratory illnesses, have impacts on the cardiovascular system, and also cause increased risk of neurological disorders. So sustained exposure to particulate matter from smoke can be fatal, especially with persons who have impaired lung function or any other pre-existing health problems. And also exposure to smoke particulates above safe levels can cause chronic impacts that would reduce life expectancy. And of course, this would increase pressure on public health systems. So about the climate change or the global change in wildfire events, I should say. This diagram shows the two of the scenarios called the representative concentration pathways, RCP. So we have the RCP 2.6 and the RCP 6.0. And the RCP 2.6 would be the most conservative scenario in terms of future climate predictions and emissions. So regardless of the scenario that is presented in terms of climate change and global change and future climate change, by the end of the century, the likelihood of catastrophic wildfire events will increase by a factor of 1.31 to 1.57. So even under the scenario with the lowest amount of emissions, we will likely see a significant increase in wildfire events. So regardless of the scenario, there's predicted to be an increase in wildfire events. So a little bit more, I have all the concentration, the RCPs here. And the numerical values of the RCPs would be the radiative forcing, which the radiative forcing would be the radiation, the radiative forcing as a result of these emissions, these greenhouse gas emissions. And if you look, even with the most conservatively lowest emissions scenario, you will still get an increase, a smaller increase or a more moderate increase, but it still will be an increase in wildfires. These RCPs are used to build these future climate scenarios, as I said, in terms of the greenhouse gas emissions. So these would depend on the efforts taken to limit greenhouse gas emissions. So the high efforts, as in trying to limit as much as possible, would be RCP 2.6, but then low efforts would be under RCP 8.5. But even under RCP 2.6, wildfires are predicted to increase. So this diagram shows a potential reinforcing feedback loop of climate change on wildfires. So basically, in terms of climate change, you have a loop. Climate change is predicted to have more extreme weather. So things like rainfall anomalies, strong winds, more dry lightning, higher temperatures. All these will lead to longer wildfire seasons. So the rainfall anomalies will be droughts, for example. These would lead to longer wildfire seasons. And of course, this will lead to increased wildfires and intensity. And then you have biomass change or thawing permafrost, direct carbon emissions, which then feed back into the ambient air pollution and the greenhouse gas emissions, which then feeds back into climate change. And we have our loop going again. So climate change will directly affect the frequency and magnitude of extreme weather that is conducive to the outbreak and spread of wildfires. And it will also lead to longer wildfire seasons where you might have the fire season beginning earlier and ending later. Not a good thing. And as we saw from this feedback loop I showed, the increased wildfire activity can positively impact greenhouse gas emissions that reinforce climate change drivers. And this is from a UNEP report in 2022, a very good report that's listed in my references on climate change and wildfires. Really, really insightful. So moving on a little bit more now to climate change and air quality. So we see climate change favoring atmospheric temperature increase, whether natural or anthropogenically caused. And this will lead to, for example, something like an increased demand for indoor air comfort, so air conditioning, especially in a region like ours where the mean daily minimum temperature is greater than 18 degrees Celsius. And then this leads to increased energy consumption. And this then can lead to increased air pollutant concentration. So for example, particulate matter such as black carbon and greenhouse gases. So we see we have this continuous loop of things going on. So the long-term cumulative effects of greenhouse gases, global warming, it's an important indicator of climate change, and that's an important indicator in terms of that cumulative effect of greenhouse gas emissions increasing. So climate change is expected to alter the concentration of airborne respiratory allergens because of CO2 and temperature's impact on plant growth. And this would impact the health burden of meteorological events such as windblown dust and mold. So a lot of things are related and a lot of things are going to impact each other. So I looked at the 6th assessment report, the most updated report from the IPCC Working Group 1, the physical science basis, and I want to highlight a couple things for you. So there is high confidence in terms of observed warming in the small islands, and this has been attributed to human influence with medium confidence. And the warming will continue in the 21st century for all global warming levels and future emission scenarios, further increasing heat extremes and heat stress, and there's high confidence in that. Small islands will face more intense but generally fewer tropical cyclones, except in the central North Pacific where frequency will increase. The other small islands would include a lot of the Caribbean islands, and it's medium confidence at a global warming level of 2 degrees Celsius and above. And I'll tell you a little bit more about why I also mentioned the tropical cyclones in a minute or two. So for the Caribbean, in terms of the sixth assessment report, they say that there's a declining trend in rainfall, or there will be a declining trend in rainfall during June, July, August. And this will continue in coming decades. And there's high confidence of that at a 2 degrees Celsius global warming and above. And also, higher evapotranspiration under a warming climate will result in increased aridity, increased dryness, and more severe agricultural and ecological droughts in the Caribbean region. And there's a medium confidence at a global warming level of 2 degrees Celsius and above. So we can see right away how these implications are going to play out. So climate change is predicted to impact air quality by altering the concentration and distribution of major air pollutants, particularly carbon dioxide, ozone, fine particulate matter, and aeroallergens. Extreme weather, such as hurricanes, heavy precipitation, and flooding, create environments conducive for mold, mildew, and other bioaerosols, and studies have shown this. And remember, the prediction said more intense hurricanes. Even though they may be fewer, for certain smaller islands, more intense hurricanes would mean that you're going to more than likely have more rain as well. And these environments are conducive for mold, mildew, and other bioaerosols. Climate change is expected to have a major impact on terrestrial ecosystems of islands such as ours, and this would increase the amount of atmospheric carbon, because if you have a reduction in the vegetation, you're going to have a reduction in what is sequestering carbon from the atmosphere. And if you have a reduction in the vegetation, etc., the forests and so on, you're going to have a lot more atmospheric carbon release, and we don't want that. And this is going to be made worse by poor land use management, indiscriminate forest and bush burning practices, of course, industrialization, urbanization, rapid population growth, and of course, an increase in energy demand by both citizens and tourists. So the expected increases in environmental exposure to particulate matter, such as black carbon, soot, and Saharan dust. You also have pollens, mold, other bioaerosols, and ground level ozone. We will have expected increases in environmental exposure to these things. And we also said we would have increased atmospheric CO2 levels. So a study that was done in 2011 and 2016 showed that increased atmospheric CO2 levels would be associated with an increase in ragweed. And ragweed is something that a lot of people, quite a few people, are allergic to. So these are examples of things you can expect under climate change and these climate change scenarios. And ragweed flourishes in tropical and subtropical climates and is native to Guadeloupe, Jamaica, and Martinique. And also, studies have shown that aeroallergens from pollen-producing plants are expected to increase. So let's move on to Zoom poll question 3. Which of these do you think is useful in preparing for an air pollution event and protecting those most vulnerable? Observations, predictions, advisories, or all of the above? So which of these do you think is useful in preparing for an air pollution event and protecting those most vulnerable? Observations, predictions, advisories, or all of the above? What do you think? I'm excited to see what you think. All of the above, 97%. All right, awesome, awesome, awesome. So let's keep going. I'm going to tell you a little bit now about vulnerability and some tools and how we can help those vulnerable, or how we can prepare and protect. So who is vulnerable? Air pollution affects people throughout their lifetime. So in pregnancy, an unborn child could be born with low birth weight. In children, asthma, slower development of lung function, other development problems, more wheezing and coughs, etc., are also going to be a problem. In adults, asthma, heart disease, stroke, lung cancer, COPD, diabetes. And then we have the elderly, asthma, accelerated decline in lung function, lung cancer, diabetes, dementia, even heart attack, heart failure, and strokes. So throughout their lifetime, there are people who throughout our various stages of growth, there are people who are vulnerable to air pollution and degraded air quality. So air pollution affects everyone, but we realize there are some that are more vulnerable than others and more exposed than others. Older people, pregnant women, children, those with cardiovascular disease and or respiratory disease, and communities that have poor air quality. So we have those who have inequalities, there are inequalities in exposure that you would end up having a greater impact of air pollution on certain parts of the population or the community than others. So who is most impacted by air pollution? Children. Pneumonia is the leading cause of death in children under 5 years of age, and air pollution is a major risk factor. Women. Women working in smoky kitchens are exposed to high levels of household air pollution. And we have outdoor workers, those who are working outdoors, street vendors, traffic officers, construction workers, utility companies persons. Now, what I wanted to note, and I had mentioned it earlier, the impact of air pollution on children's health. I had mentioned the indoor air quality earlier, some statistics with that. So the impact of air pollution on children's health is something we really need to pay attention to. Because a child who is exposed to harmful levels of pollution can face a lifetime of impacts on his or her health. And exposure in the womb or in early childhood can lead to stunted lung growth, reduced lung function, and increased risk of developing asthma, respiratory infections, impaired mental and motor development, behavioral disorders, low birth weight, premature birth, infant mortality, childhood cancers, an increased risk of heart disease, diabetes, and stroke in adulthood. In 2016, ambient and household air pollution caused 543,000 deaths in children under 5 years and 52,000 deaths in children ages 5 to 15. Household and outdoor air pollution caused more than 50% or causes more than 50% of acute lower respiratory infection in children under 5 years in lower and middle income countries. So our region is a region that would be affected like that. So how can we prepare and protect? We have observations. We have what we call remote sensing observations. So things like satellite, which would help a region like ours, where we don't have a high density of surface particulate matter or air pollution samplers. So satellites also help, but it's also good to have the surface observations, which would be the samplers for particulate matter and other pollutants. Predictions are also very important. We have models that actually not just model weather, but can actually model weather and the chemistry to let you know ahead of time what to expect in terms of certain key pollutants and particulate matter. So you can get forecasts on that. And then putting some of these things together, you can get advisories, both short-term and seasonal. So as an example, I talk about the WMO Caribbean Regional Climate Center, hosted at CIMH, along with our Dust and Air Quality Forecasting Center. So the RCC, which is the Caribbean Regional Climate Center, puts out a health climatic bulletin that is seasonal. The Dust and Air Quality Forecasting Center issues advisories for a 7-day forecast of Saharan dust and particulate matter. And then there are other mitigation strategies which we can discuss as we go on in the discussion section after the presentation. So this is an example of what I'm talking about in terms of observations. We have what we call the Gold 16 satellite. This is a satellite that is over our region, and it has various environmental weather parameters that are monitored. And the example I have here is showing the dust event, the actual Godzilla dust event that we had in 2020, that mega dust event. And if you look at this is what we call a geocolor imagery in meteorology and atmospheric science, where you actually can see the color, the real color of the phenomena you're trying to examine. So you can see the dust has the dust color, and you can see we can actually look to see when a heavy dust episode is coming across the Atlantic to affect our region. At this time, the dust plume was over a good part of the region, but you could see that coming from the east, there was more dust expected. So this is something we use in monitoring. This graph is actually even more atmospheric science level stuff, but if you look at the graph, you will see you have peaks like with any other graph. And this is something called aerosol optical depth. And we use this also as a parameter to measure how dusty the air is or how many pollutants are in the air. In this case, this would be Saharan dust because this is at the Ragged Point station. And when you have these heavy dust episodes, you get these high aerosol optical depths, which we call AOD. So we can also monitor that way as well. So that's observations. But we can also warn persons in advance when you have a decent model. Now, this is what we call the WRF model, WRF, Weather Research and Forecasting Model. And this model has various components. It's a good weather model. We use it for predicting our regular weather and also when we have hurricanes, tropical cyclones, etc. But this is the version we use to do predictions of dust concentration and PM 2.5 and PM 10, along with aerosol optical depth. And so 7 days in advance, we have an idea of when an intense dust episode is coming across from the African continent. So this is also very useful as well. And then we can put this information together in an advisory. So in the case of the Caribbean Health Climatic Bulletin, that would be a seasonal advisory of sorts, or seasonal bulletin. And this example I have up here would be March to May 2022. So you have an idea of what would have been happening from March to May in terms of the weather and climate and things including the Saharan dust and possible fallouts from air quality in that. And then this is an example of on the right-hand side, the Saharan dust update, where we would take the 7-day forecast from the model. We look at the conditions on the satellite. We look at the observations, and we look at the model predictions to give an update on what the air quality would be like based on the Saharan dust, any upcoming or impending Saharan dust intrusions. So before we finish up, I have one open-ended question. You can type in the chat your answer or any ideas you have, or you can even talk about it during the discussion. So one thing I want to leave with you: how can health professionals protect the vulnerable persons in our communities? I may have given you some ideas based on what you've seen in terms of tools and resources, but feel free to type in the chat, how can health professionals protect the vulnerable persons in our communities? So I'm looking forward to seeing your answers, your suggestions, your ideas in the chat. And I also think it's also useful because a lot of us here, we are an interdisciplinary group. And I think the dialogue among us would really help also to find some answers to questions such as this. Because as you would notice, health professionals protecting the vulnerable persons in our community would actually also include using tools from the atmospheric science community, environmental science community, etc. Oh yeah, and see the answers coming up. Oh wow, nice, nice, nice. things such as educate targeted audiences, conducting health sessions, provide advisories and related health education. Someone said mostly through education and public health intervention. Ooh, they're coming fast and furious. Lovely, lovely. Yes. I see someone, I glanced at one where they say being aware of the climate change, which is also important too. Behind, yes, yes. Awesome, awesome. I love it. I love it. So I have my references here, and you will see them in this slide deck. There are quite a few of them, so you can have a look. And thank you very much for your attention, and I look forward to your questions, and I look forward to us having a really engaging discussion. And I am looking forward to learning from you as well, and not just you learning from me, but we all learning from each other. So it has been a pleasure to share with you this evening. Thank you.
Thank you, Dr. Seeley, for a very informative session. It was indeed very clear, and we were able to learn a lot. I must say that you have scared me quite a bit, though, because last week we learned about heat being a silent killer. But I think this week we have learned even more, maybe, that air pollution is probably an even more detrimental force in terms of wiping us out in terms of our morbidity and our mortality, especially when we are thinking of the most vulnerable in society. Well, without further ado, I would like to introduce, it is a great honor to introduce Dr. Hima Babilao, who is going to join the panel discussion this evening. Dr. Babilao completed her doctoral studies in characterizing air quality in Trinidad's West Coast. Her passion and her expertise are in the environmental sciences, with a particular focus on air quality, how it is monitored and how it is managed, both ambient and household air pollution. She did her master's degree at the University of Strathclyde in the UK and currently lectures in pollution biology at the University of the West Indies, St. Augustine campus. Welcome, Dr. Babilao.
Thank you so much, everyone. Dr. Seeley.
Welcome, Dr. Babilao. Maybe you could just share a few words with us before we begin the panel discussion. We have a few interactive questions that we need to answer, but maybe you could tell us a little bit more about what drew you to this air pollution, climate health crisis that has made you so passionate about making a difference.
Well, I can say I share Dr. Seeley's passion in that you can see how the environmental field is multidisciplinary. Everything has to do with the quality of life for what's around us, our fellow man, our fellow animals, the ecosystems around us. And to me, air pollution is one of those things that just does not get enough attention. And is the one thing we can't do without is air, is breathing. And whatever is in the air, we breathe in. And it is so poorly characterized. We don't know what we put in there in our lungs. We don't have much choice about it. So I thought, as a scientist, this was my calling. I have to address, this was a great data gap, and it had to be addressed because there was so many implications.
So yes, before we pose some questions to both of the panelists this evening, I must say that I felt a bit concerned because in the region, we are being exposed to increased industrialization, increased urbanization. We're having more vehicular traffic, increased Saharan dust events, as we have more drought in the Saharan dust, in the Saharan desert. And he also painted a very grim picture about wildfires. I was not aware that when we actually burn the forests, that we are releasing so much carbon dioxide into the atmosphere, and that has a very negative effect in terms of the cycle it's a negative cycle that we are seeing. And the fact that by the time we reach the end of this century, regardless of whether we have the best, we are doing the best that we could in terms of limiting the degree rise in centigrade, we are still going to be worse off when it comes to wildfires in terms of having more wildfires and more air pollution. So let me ask the first question that we seem to have some interest in here. So we want to find out what mitigation strategies can we use to protect the more vulnerable. You brought this up, but maybe you could just summarize again, either one of the panelists on this mitigation strategies that we can use to protect the most vulnerable. And specifically, I was thinking in terms of the pregnant moms, pregnancy, because we know that those are the most vulnerable in society.
Okay, well, I can take this one. This one's kind of easy because we can see, places like China and Asia, they've had dust problems for a long time. And to protect themselves, they wear masks. So there's absolutely nothing wrong with wearing a mask outside of COVID. Wear a mask to protect yourself from particulates if you're outside. If you think you will be vulnerable, if you think it's going to be a problem, you can wear a mask when you're outside. You can't do too much else about the gases, but you will be well advised. People who jog, it's not a good idea to go jogging near traffic. When you go jogging near traffic, you're exercising, you're breathing in your lungs full of air, and you think you're getting your body healthy, but what you're doing is putting particulates, but everything that's absorbed onto it, all those volatile organics, all those black carbon, all the nitrogen dioxide and ozone, all of that is what you're breathing in. So do not exercise around the savannah or near busy highways and roadways. It's just not a good idea. And indoors, generally indoor air is a poorer quality derivative of outdoor air. So it's a good idea to ventilate, open your windows and ventilate as much as possible. Those are some of the things that we can do, everyone can do.
Okay, this is really good to know. Another question that came in concerned anesthetic gases. We know that nitrous dioxide, nitrogen dioxide is one of the anesthetic gases that we use commonly. However, I am aware that the volatile anesthetic gases, which are halogenated, seem to be worse for the environment. I do not know if either of you have any comments in terms of the volatile organic gases. I know there is some say, or there is some evidence to say that they actually destroy the ozone layer. I don't know, can any of the panelists probably comment on this, please?
Okay, what I just heard you, well, actually what just piqued my attention was where we were talking about the destruction of the ozone layer. The issue with I'll tackle that first. The issue with the ozone layer is that there are certain compounds we use, like in aerosols, refrigerants, etc., that when they're released, they can destroy stratospheric ozone, which also is a problem for us because stratospheric ozone, which is the ozone at higher levels, the ozone layer, is the good ozone that we need to protect us from harmful ultraviolet radiation from the sun. So that is something I didn't even mention in the presentation, but it's a very good point to note that this also is a climate change issue in terms of the fact that we actually had gotten to a point with the Montreal Protocol and the subsequent protocols where we were able to replace and phase out certain compounds that would destroy the ozone layer, but then some of those that we replaced them with are actually greenhouse gases. So then that was a problem because we were still using those, and we know greenhouse gases would be causing increase in global warming and increase in atmospheric temperatures. But yes, that is a problem. But what I wanted to ask, because it's not my field, the NO2 that is used, that's in anesthesia, how is it? The question would be, and this is me as an atmospheric scientist talking, the issue I'm looking at in terms of NO2 would be released into the atmosphere. So what is the feedback in terms of what is used for anesthesia? Because what I'm looking at is NO2 emissions. So from my point of view, I'm looking at maybe that is not emitted. I am not sure. But the issue I see is the NO2 emitted from the combustion, etc. I'm not sure what the feedback would be in terms of the NO2 used for anesthesia. Maybe someone can enlighten me on that.
Maybe,
So that's
but
what
so I was thinking, I know locally we use NO2, right, as anesthesia, but local anesthesia and also
Right.
for gases. But unless Dr. Babilao knows whether this gets released into the household air pollution.
Because the issue would
I'm
be
not
release.
sure. It's not been touted. It's not been touted. Significantly affecting ambient air pollution. To my knowledge.
Right. That is what I'm not sure about. But I know the concern would be the release into whatever environment, whether household or ambient. But Dr. Babilao could probably shed some light on that too.
Thinking about it, I think maybe in comparison to things like combustion of fossil fuels from stacks, from vehicle emissions, it's probably very, very small.
Very minor. Yes, I agree with you. Yeah.
So there are many other things like the halogenated cleaners and the degreasers used for sterilization. Those stick around in the atmosphere for decades. Have more of an impact on quality, adding to the VOC load in the breathing air.
Yes, and those compounds that destroy the ozone layer, I forgot to mention, since you talked about lifetime, their lifetime in the atmosphere is on the order of decades to century. So those are also, that would also be a major concern. Yeah.
Okay. I need to ask Haley to read the questions. I'm not seeing them posted. But while she's doing that, I need to tell you, I need to remind you, if you want your CMEs, please, you need to pay by next week, Wednesday, the 11th. And the link for the payment is posted in the chat, but it's also posted on the consortium website, right? If you go down all the way to frequently asked questions, you can get the link there. And you could also get the link on the EarthMedic EarthNurse website. Kelly, are you able to read the next question, please, for the panelists?
Yeah, absolutely. Hi, everybody. My name is Haley Campbell. I work with Columbia University at the Global Consortium on Climate Health Education. I can jump in really quickly, Paula. We have a question from Vanessa Green. It's actually something that I'm personally really interested in, hearing your responses for. So what are some modifiable risk factors that make specific groups more vulnerable to air pollution?
One of the things that jumps into mind is small children. Small children breathe in more air per body size than adults. And sometimes they're like in Trinidad and Tobago, the classrooms are not always well ventilated. They're always very packed. And especially with COVID, now that they're going back to school, they tend to want to keep the children wearing their masks. So it's very hot. And there are a lot of exhaled gases in this indoor space. So I think the concept of ventilation where children, in areas that children occupy, should be something that is given priority. I don't expect that COVID-19 might be the only pandemic we have in the next few decades. So I think we have to start giving more attention to the quality of air we have inside. It's not just if it's air conditioned, it's fine, because the air conditioning only solves the relative humidity and the temperature problem. All the indoor gases are still there. People are still breathing out and breathing in. All the carpet and adhesives are still releasing volatile organics, and children are most vulnerable to this.
Okay, thanks a lot for that. I also would like to say that in the case of children, sometimes we find when they play outdoors, especially when there is a lot of dust, sometimes when there are, say, playgrounds are dusty, especially in hot environments, we find that these children are more prone to developing probably they're more prone to developing respiratory infections, more prone to having asthma and allergic. So that teachers and parents should be aware of this, that they would need to keep their children indoors, well hydrated in times when we have a lot of dust in the atmosphere. Okay, so we have a question from Wycliffe. I hope I'm pronouncing that correctly. To what extent do international or intentional fires and landfill burning contribute to air pollution? I can't see the question properly. Yes, to what extent do unintentional fires and landfills contribute to pollution in the atmosphere, air pollution? Dr. Babilao, I think you might want to answer that.
Okay. Well, recently, a couple of weeks ago, Trinidad had a big problem with fires at the Beetham landfill, which is a major landfill just outside the capital city of Port of Spain. And it's the culture is not to sort garbage. So all household garbage, some commercial garbage is dumped in trucks in different areas and covered over with soil. So there is that release of methane, that slow diffuse release of methane and all the other volatile organic compounds and things that are a result from biodegradation that get released into the air. And when there was a fire, that added combustible material, organic material, burnt, volatilizes things that would not normally volatilize at room temperature. So all of that soot and black carbon got released into the atmosphere, got blown into the wind into the capital city, and created a lot of hardship for a lot of people that were working in Port of Spain. So I think landfills in Trinidad and Tobago, and maybe in the rest of the Caribbean, where we do not have a culture of separating our garbage from plastics and organics and chemical waste, that this needs to be prioritized for addressing. For one thing, you cannot harness it. Diffusion is usually, dilution is a good solution to pollution. It used to be, but now we've loaded up our atmosphere and our general environment with so much pollutants that we now have to start treating our waste, treating our contaminants. So unless we start segregating our waste, there is no possibility for us to properly treat that waste, because you can't, nobody is going to go in the dump and sort out anybody's garbage. It's something that has to happen at a household level or at the point of collection. So the whole waste collection process has to be rethought, with the aim being we need to reduce greenhouse gas emissions and we need to treat our waste and not just dump and cover, because it's not sustainable.
So somebody asked a question about the measurement of the gases that may be coming out of the landfills. Are they regularly, how are they measured? You know, are they regularly measured to inform probably people who live around there? Dr. Babilao, maybe you might want to give us a little more information on this.
My experience is that monitoring is not such as efficient as it should be. For my doctoral work, I did do some measurements in the landfills, in 2 of the landfills on the west coast of Trinidad. And I measured dioxins, furans, quite a few organics. Methane levels were above 15 ppm, which is quite high. The ambient is usually about 1 point something, 2 point something ppm, but in the landfills, it was a lot and it was diffuse. And there are a whole host of organic compounds, formaldehyde, many things that are cancer causing, that are just off-gassed and enter the atmosphere, and it goes wherever the wind blows. Nitrogen dioxide from traffic, from it being near the capital city, interacting with volatile organics in the air, creating secondary pollutants, peroxyacetyl nitrates and ozone, it's going to affect anybody who's breathing it. And there's no shortage of sunlight in the Caribbean. So we have all these photolytic reactions happening, and you have high concentrations of these pollutants building up wherever the wind will blow, and people breathing it if you're outside. You don't have any control over what's outside, and a mask, though it may protect you from dust, will not protect you from toxic gases. So it is a matter that needs addressing.
So this one is for Dr. Seeley. This comes from Karen Lewis Bell. She asked about the advisories to the countries about climate change and how we could get information when we're having events. Is this just for Barbados or for the other Eastern Caribbean countries, the advisories?
Our advisories are for the Caribbean region. So the climatic health bulletin that I mentioned, that is put out by the Regional Climate Center, is for the entire Caribbean region. And the shorter term advisory, which, for example, the one we put out for the Saharan dust, that is also one that we try to also get distributed to the region. So what we have done, because I usually send out the Saharan dust advisory, which is based on the 7-day forecast. That one I send out to CARFA and PAHO for distribution throughout the Caribbean region. And the climatic health bulletin is also sent out to a similar audience as well. So not just for Barbados, for the region.
Where is that posted? I mean, where can you see that so we can
the link for the climatic health bulletin, that is usually posted on the web, and the link I gave for the Regional Climate Center, you can find the latest climatic health bulletin there. What we usually do with our Saharan dust advisory, we usually email it, but we are planning to upgrade so that we can actually put it on our website for the dust advisory in the near future. Hopefully this dust season we can do that.
And maybe you could mandate it coming to our local institutions, organizations like the EMA, so we don't have to look very far.
Yes, yes. So we have to work on that channel of distribution, definitely, definitely.
Okay, so this comes from Dr. Sonia Johnson, and she asks, what is the instrument used to measure the impending Sahara dust intrusions?
Okay, in terms of looking at the Saharan dust intrusions, our approach is, for example, when I'm looking to do an advisory, because the dust is coming from the east and it's just ocean to the east of us, I usually look at the satellite imagery first to see how the dust looks on the satellite imagery, if there's a dust plume and it's an intense dust plume coming across the Atlantic. But once the dust gets to land masses, some of the territories, but once again, data sampling is an issue. Lack of sampling is an issue in the region, but there are some territories that have, we have the dust measurements here at Ragged Point. There are a couple other instruments here that can do some particulate matter, and there are some territories that have particulate matter and dust sampling. So you would have samplers that are on the ground, and you also have another instrument that measures aerosol optical depth, which is called a sun photometer. And the aerosol optical depth also gives you an idea of if it's a dusty or if you have a dusty event going on. So we start off with the satellite imagery in terms of monitoring, but then when the dust plume gets to land masses, there are some places that do have instrumentation on the ground to measure the particulate matter or the dust concentrations from that.
So I have an interesting question here from Patsy Armstrong. We know that we need to use our air conditions when there is a heat event. She's asking, however, how do the use of air conditions, do they become a source of concern for indoor air pollution?
Air conditioning can be a problem only if you don't have adequate ventilation. So I've sampled workplaces where they have air conditioning all the time, but they don't open the doors, and you have 15, 16 people, and the carbon dioxide level was like 1200 ppm, 1500 ppm, where people are sick and sleepy all the time. So having your air conditioning on for a night, for a day, should not be a problem if you open the windows every so often to have that exchange of air and make sure your house is properly ventilated. If you have a gas stove, make sure your extraction process is proper. If you have a gas stove, open your kitchen window. That's enough to blow your fumes out to make sure you don't have a buildup on the inside. So I think that should help. But
Okay, let me go to the next question. Is from Vanessa Green. And she asks, is there a direct link between air pollution and the prevalence of non-communicable diseases like diabetes? Maybe I could have a stab at that as I'm a physician. So there is a direct link between air pollution and the prevalence of NCDs, although we see that there are some diseases that there are greater risk of developing, specifically the respiratory diseases like asthma and COPD and bronchitis and pneumonias. However, interestingly enough, very recently, we have been seeing coronary artery disease, plaque rupture, acute cardiac events being associated with air pollution. And how this happens would be so that if you have air pollution, say doctor spoke about the average mean being 10 micrograms per meter cube. So if you have chronic elevations, what you get would be plaques occurring in the coronary arteries. If, however, you have a surge, like for instance, what happened in the landfill fires recently, what we find is that people who already have coronary artery disease, they have plaque vulnerability, and therefore you will have an increased incidence of both stroke and myocardial infarcts following poor air quality events. Okay, let's see. People wanted to know if wildfires specifically were increasing in the Caribbean, and if so, which countries seem to have had the worst problem?
I have to look, but I remember looking at some of the research I was doing and some of the reading. I can't remember offhand which countries, but there were some studies that looked at specific countries, but I can always get the information and send it to you. But in the region, yes, wildfires have increased. I think one I saw was either a study, I'm thinking, I'm subject to correction, it may have been Jamaica, but I can't remember exactly. But I saw one or two studies that were for specific islands. But right now I can't remember offhand where they said there were actually increases in wildfires. Yes.
Okay, now we have a problem where sometimes we would lose electric power in the Caribbean, not uncommon. And we find that there's an increasing use of generators to supply electricity. I know our own Dr. H. Hospitalis here, he has decided that he was going to invest in solar generator. I don't know if Dr. Hospitalis will jump in and tell us a little bit more about generators to supply energy as a source of concern for air pollution, or if we would leave that over to Dr. Seeley. Dr. H.
Thank you, Paula. Yeah, definitely. Generators, diesel generators are often a source of problems. I know in Dominica, for example, after Hurricane Maria, a lot of people were using generators in close quarters, and you had a lot of complaints about air pollution from neighbors and people in the same household that they were experiencing asthma, bronchitis, and a lot of irritation from the air from the exhaust from the generators. That's partly why I decided to switch to a solar power backup system for our home, and which is also Earthmedic headquarters.
Oh, okay. So how easily is it available for us to get the solar power generator? At least in Trinidad and Tobago.
Yeah, it's not a solar power generator. It's a photovoltaic system. You have the panels on your roof.
Okay.
Many countries are you seeing more and more of it, and you have a battery backup bank so that if the electricity goes, it's seamless. You have your electricity continuing. A hospital or a doctor's office that has such a facility would not need a backup generator and would be able to have continuity of patient care without vital areas going down. In Trinidad and Tobago, these things are still subject to tax. We really need a policy that reduces or eliminates tax and tariffs on photovoltaic panels and makes it easy for people to have them installed. They're not too difficult to maintain, but there is a maintenance aspect. You have to clean the panels, you have to maintain the batteries, so they can't just be ignored over.
Okay, that's really interesting and something we should think about investing in, especially at this time when we are very concerned about pollution and particulate matter. We have just about 2 more minutes, so probably this is a question I have been toying about. My family, we are very much like to recycle and we like to take things back to the earth. And so we have composting in our house. So any wood or trees that are cut, they are composted using a compactor. The problem I have with that is that we get a lot of particulate matter being introduced into the atmosphere. So I don't know if anyone has any comment on that, because while we're thinking, yes, we should be composting and putting things back to the earth, I'm thinking that while we are composting, because it is a machine that's chipping the wood down, while we are composting, we also contributed to particulate matter in the atmosphere. Any takes on that?
Well, it depends. Size matters, right? So if you have large particulates, they will settle out to the atmosphere first. It's the really fine particulates, especially gas phase reactions like burning diesel, and so that tends to generate the particulates to stick around for days and weeks. So it's you don't have to worry too much about composting, creating particulates that can stick around for a long time. One shower rain and it gets rained out.
Okay, thanks for that. Okay, this question comes from Tamika Daniels Wilson, and she's asking about the link between air pollution and cancers. I know that there has been research being done where we know that particulates are carrying carcinogens, specifically benzene and cadmium. So can you give us some feedback on air pollution and cancer, please?
So there's definitive work that's quite old now, but maybe 20, 30 years old now, by Dockery and a few others that were instrumental in pushing legislation to regulate particulates. Whatever is stuck onto the particulates, like burning vegetation in Trinidad and Waterloo, would have a lot of cadmium in it, because cadmium is a frequent pollutant and it is bioaccumulating in biota. So when there's a wildfire, it gets volatilized in the particulates. It's found in the particulates that you will inhale. Particulates, respirable particulates, the smaller it is, the deeper it goes into your lungs. The deeper it goes into your lungs, the longer the retention time. Therefore, the more biologically active particulates are the finest ones. Whatever's on it gets leached and creates dynamics at the cellular level that would affect cancer. So there is definitive work that proves a cause and effect. And you know how hard it is to prove cause and effect. Cause and effect, that particulates in the air and pollutants in the air increase death and mortality rates from lung cancer, cardiovascular disease, and stroke.
And that is really, really true. So just to remind you that particulate matter is just particulate matter, and it can carry a lot of stuff. It's like a bus, right? So it's carrying carcinogens, it's carrying certain gases, it's carrying pollens and allergens. It's just a bus that's carrying a lot of stuff. And as Dr. Babilao said, and as Dr. Celia alluded to, the smaller the particles, the further into the body it could go. So the big ones get stuck in the lungs, but the large ones get to almost every organ and causes destruction. Just a reminder, please fill out your CME, the link if you want CMEs. Also remember to pay the link if you have any issue. Remember that we're available. You could always email Haley, or you could all email me, phenry@goodmedic.com. I would like to thank the panelists for coming this evening, for giving us such an easy ride, giving us so much information. And I would like to know if there is anyone who would have any 30 seconds closing words. No takers? Okay, well, in that case, I would like to thank everyone. It has been a great evening.